This video is for 12 specialists. It comes out of Chapter 6, Implicit Differentiation. That's question number 13. And it's a bit of a tricky question. Okay, so first off, I need to take the derivative. And because I've got an expression in terms of y and x, when I take the derivative, it has to be implicit differentiation. Otherwise, I have to rearrange it for y equals. So it's easy to take implicit. So dy dx in terms of x and y. So the derivative of y squared, so I have a chain rule. So that's 2 times y to the degree of 1 times the derivative of the inside, which is dy dx, plus the derivative of x cubed is 3x squared, equals the derivative of 1 is 0, which means that dy dx equals minus 3x squared divided by 2y. Okay, so that's part A done. Now, part B says find the coordinates when dy dx equals 0. Okay, for something to equal 0, the top has to be 0. That's the only way that dy dx can be 0, because if the bottom is 0, we have an undefined situation. So, minus 3x squared equals 0, therefore x equals 0. And I need to find the coordinates. So when x equals 0, y squared equals 1, therefore y equals plus or minus 1. So I have two answers to this. Dy dx equals 0 at 0 and 1, or 0 and negative 1. So that's part B done. Looking at part C, I want to find when dx dy is equal to 0. So dx dy will equal 2y on top of 3x squared, and the same logic applies. That's only going to equal 0 when the denominator is equal to 0. Whoa. Sorry, when the numerator is equal to 0, and that's going to be when y equals 0. And if I have my expression, which is this, y is only going to equal 0 when x cubed, so 0 plus x cubed equals 1, therefore as x equals 1. So 1 and 0 is the time when dy dx equals 0. Now, a little bit of a think about what dx dy means. If dy dx equals 0, the gradient is 0, which means it's a horizontal line at that point with a gradient of 0. Dx dy equals 0, well, that's this flipped upside down, which is sort of like the gradient is 1 on 0 or undefined, which means the graph is totally vertical at that point. So if the derivative exists, that is, it's not a division by 0. If the function exists, that is, it's not a division by 0, I'm going to have a vertical line in that situation. So what have I got so far? I know that at these 2 points, the gradient is 0. And at this point here, the gradient is infinity or undefined. So, and they're the only two stationary points. So I'm thinking my graph must do something along the lines of, and either go down or go down. But I've only got two stationary points, this one, and this one is vertical. And I'm thinking that I've got a restricted domain that x can't be bigger than 1. But anyway, let's have a little look at the rest of the question. Describe the behaviour as x approaches negative infinity. So if x goes to negative infinity, so what have we got? Y squared plus x cubed equals 1. If x goes to negative infinity, then x cubed also goes to negative infinity, which means y squared will equal 1 minus x cubed. So y squared will equal 1 minus infinity, so y squared is going to equal infinity, which means y could equal plus or minus the square root of infinity. Now, you can never get to infinity. It's an incredibly big number. So if y equals infinity, then y squared would equal infinity as well. And if y equaled negative infinity, y squared would also equal infinity. So as x goes to negative infinity, y either goes to infinity or y goes to negative infinity. That makes sense over here because as x gets towards negative infinity, y is either up here or down here. So I'm thinking that because as x gets to negative infinity, y is approaching either infinity or negative infinity. But anyway, let's have another think. What else do they ask us? Express y in terms of x. Well, y squared equals 1 minus x cubed. So y either equals the square root of 1 minus x cubed, or it equals the negative square root of 1 minus x cubed, making me think that this one is the positive square root and this one is the negative square root. Find the coordinates of the points of inflection of the curve. Points of inflection will be when the second derivative is equal to 0. So what was my first derivative again? Dy dx, where are we? Dy dx equaled this, didn't it? So y dash equals minus 3x squared on 2y, and I need to do the quotient rule on this. So equals u on v, u equals minus 3x squared, u dash is going to equal minus 6x, v equals 2y, v dash is going to be 2 dy dx, which means that y dash dash starts with v, so it's going to be this times this, minus 12xy, minus, but that's already a negative, so plus 3 times 2 is 6x squared dy dx, all on top of 2y squared. It equals this. There's a y, there's a y, there's a dy dx. I've replaced y with 1 minus the cubic root squared. I took the positive answer, and when I did dy dx, which was minus 3x squared over 2y, I took the positive answer. I could also go through and do the negative, but I think that we have symmetrical situations. So wherever I have a point of inflection in the top half, I'm going to have a point of inflection in the bottom half. And looking at my graph, I'm thinking my point of inflection is going to be here, because it seems to be that's where it then flips around, but we'll check and see. So I only took the positive square roots, and I've replaced dy dx with that, and then I've replaced y with this, and I've got 4y squared on the bottom. If I want to set that equal to 0, I could ignore the bottom, because it's only the top that's going to give that to me. So if I then have minus 12x all on top of 2 the square root of 1 minus x cubed, then that will be 1 minus x cubed, and that's already over that, so plus 6x squared times minus 3x squared. I can ignore the bottom because the bottom will then go into the numerator, into the denominator. So if I multiply this out, I got minus 12x plus minus 6x x cubed minus 2, which means x equals 0 or x cubed equals 2, which means that x equals the cubic root of 2. So there are 2 times that the second derivative is equal to 0. However, this one is outside of the domain, because if y equals the square root of 1 minus x cubed, therefore I have an implied domain that x has to be less than or equal to 1. And since this is bigger than 1, I can get rid of that, which means that I only have points of inflections at 0 and 1 and 0 and negative 1. And then part G, have a little sketch, and I think that this is what my sketch is. It confirms what I'm thinking. So that's the graph of y squared plus x cubed equals to 1.